Hello students, in this video we are going to see about subnetting concept in computer communication. So we are going to look at for IP version 4, in IP version 6 we are not having the subnetting concepts. In IP version 4, as we all know, the length of the IP address is 32-bit length. 32-bit binary numbers will be there, sequence of zeros and ones. But generally we are using two notations to represent an IPv4 address. One is decimal number, another one is binary notation, and this is a decimal number notations. Normally when you are doing our experiments by using Cisco packet tracer, we'll be setting the IP address to the end devices and to the router, and usually we are using this class of IP address 192.168.1.0, and its equivalent binary notation is this one. IPv4 is made up of 4 sections. The first section 192 is represented as this 8 bits. So here you can see 8 bits. And the second section 168 is represented as the next set of 8 bits. The next set of 8 bits represents the third number 1. The last 0 is represented by last 8 bits. But as a whole, it will be the continuous sequence of 32-bit. But for our convenience, we are breaking into 8 bits since it corresponds to the respective sections in the decimal notations. Classful addressing. So we are dividing the IP address into two sections. Each IP address has two sections. One is network ID, another one is host ID. So the 32-bit length IP address will be divided into two parts, network ID and host ID. Based on the length of net ID and host ID, we are having 5 classes. So the classes are named as A, B, C, D and E. Class A, out of 32-bit, the first 8 bits of the IP address represents the network ID in class A. Remaining 24 bits is part of the host ID. Class B, network ID length is 16 and host ID length is 16. So this is the main differentiator between the classes. The length of the network ID defines the network class. Either it is class A, B, C, D and E. D and E is for some other purpose, I'll be telling you. So 824. B, first 16-bit network ID, remaining 16-bit host ID. Class C, first 24 bits is used to identify the particular network, and remaining 8 bits are used to identify the particular host in a network. So what are the consequences because of this net ID lengths? So we are having 8 bits, first 8 bits to represent the network ID. So in class A, we can represent only 2 power 8 number of networks and 2 power 24 number of hosts. Host means computers. This is network NTK. In class B, we can represent 2 power 16 networks. So more number of networks we can represent in class B than class A. And 2 power 16 number of hosts. 2 power 16 number of computers can be connected in each network. Then class C, 2 power 24 number of networks can be represented, and 2 power 8 number of hosts is part of the each network. So which network can represent more number of networks? Obviously class C. 2 power 24 different networks can be represented. Different network addresses will be there. And each network can accommodate 2 power 8 hosts. So it is 256 computers can be the part of each network in class C. So class A, though it can limit it can represent only limited number of networks, 2 power 8 networks, which is the very lowest and compared with other classes. Within each network, it can accommodate more number of computers. It can accommodate more number of host system. Class B is intermediate to class A and B. So these are the consequences of net ID length and host ID length in the addressing. And also we should know what is the starting address and end address, because through decimal notation also, by looking into the decimal IP notation, we should be able to identify the address belongs to which class. The address starting with 0.0.0.0 to 127.255.255.255, all these addresses are class A addresses. Suppose if anybody is writing this 68.1.110.7, by merely looking at this number, we should tell the address belongs to which class. Obviously, it belongs to class A, because this is a lower range. Any number starts with 0.0.0.2 127. You please remember the first number 127. Within 127, it is class A address. And class B, remember the first number 128, from 128 to 191 to 191. So why I am telling, just remember the first number is always, the first number is a major differentiator. The second three sections always in all the classes it starts with 0. The last three numbers always it will be 255. So it is better to remember the first one. By looking at the first section, you can tell the IP address belongs to which class. Okay. Suppose if somebody is telling the IP address is 131.105.7.8, it belongs to which class? It belongs to class B, because it comes under this range. 131 comes under the range between 128 and 191. So similarly for class C, the starting address is 192.0.0.0 to 223.255.255.255. So this is class C address. Class D and E. Class D is only used for multicasting purpose. It is not generally used for any other purpose. When you want to multicast a packet, we'll be using the multicasting addressing, that is sending the particular information or packet to some set of systems. Multicast communication will be using these addresses. Class E was reserved for future purpose, but it was never used. Okay, so we can take, we have wasted the class E address. D for multicasting we are using. Okay. So by looking at the decimal number notation, now we can tell the given IP belongs to which class. If they are representing the IP address in binary number notation, then also we should be able to tell it belongs to which class. A very simple fact. Look at the first bit of the 32-bit binary number. If the first bit is 0, the first bit is 0 out of 32 bit, first bit is 0, definitely the IP address is class A. Whatever the next numbers you are having, it does not matter. The first number is 0, it is class A address. And if the first two numbers are 1 0, the remaining numbers can be any combination of zeros and ones, then it is class B address. The first two bits are 1 0. Class C address, the first three bits are should be 1 1 0. For class D, the first four bits should be 1 1 1 0. For class C address, the first four bits should be 1 1 1 1. So now by looking at the decimal notation of the IP address, or by looking at the binary notation of the IP address, you should be in a position to identify it belongs to which class. Now comes to subnet mask. Subnet mask is another 32-bit number which is used to identify what is the network ID length and host ID length of the given IP. Directly, I think I can go for an example. Before that, you just note it. In a 32-bit number, the network ID length, all the network ID length will be 1 and all the host ID bits will be 0. Then that address is called as a subnet mask. So the main purpose of using subnet mask is to identify the net ID and host ID length. So looking at an example, it will be clear to you. So let us take class A. Class A, what is the net ID length? Here you have a look at it. Net ID length is 8. First 8 bits are net ID. The remaining 24 bits are host ID. So first 8 bits all are 1. Follow this principle. Net ID bits are all ones. All the net ID are made as 1. The remaining 24 bits are host ID. The remaining 24 bits will be having 0. If you are converting this into the decimal notation, if you are converting this continuous 8 bits into the decimal number, it will be 255. I hope you know the conversion. Binary number to decimal number conversion and decimal to binary number conversion. And converting this 8 bit of zeros, 0, decimal number 0. Again this 8 bit of binary zeros to 0, 0. So this is the default subnet mask. Default subnet mask for class A address. For class A. Similarly for class B, what you have to do? Just look at the net ID length. For class B, net ID length is 16 bit. Host ID length is 16 bit. So if you want to find the subnet mask for class B, first 16 bits you have to write it as 1. You have to write it as 1. Okay. I'll be writing it here. 1, 1, 1, 1, 1, 1. Remaining 16 bits should be 0. So if we are converting this binary number into the decimal notation, and this will be the number 255.255.0.0. And what is the default subnet mask for class C? For that, you should know what is the net ID length of class C. Net ID length of class C is first 24 bits are net ID, remaining 8 bits are host ID. So I'm writing it. First 24 bits are ones. I made it as 1. Remaining 8 bits I made it as. If I am converting into the decimal notation, the subnet mask of for class C address is 255.255.255.0. And there is no specific net ID length and host ID length for class D and E, so we can leave it. Okay. So this is a way of calculating the subnet mask. Thank you.